Hello, hashtag WTF is SRE Conference 2022. Today we're going to talk about graph algorithms and how to utilize them to enforce best practices on infrastructure as code. We start with a famous quote of a famous SRE called Untitled Chapter. If you're afraid of downtime, don't apply upgrades to your production environment. We'll take that quote and we will try to reduce some of the fear and stress of deploying to a production environment by testing issues very early on in the development lifecycle. My name is Barak Schoster, and I'm Chief Architect at Palo Alto Networks. Before that, the CTO and co-founder of Bridgecrew that was acquired by Palo Alto Networks. During the past few years, I've seen multiple attempts for digital transformation, taking resources from data centers and trying to either shift and lift it or rewrite them and apply it in the cloud environment. And the thing that is reproducible is that some of them fail and some of them are very successful. But why does the ones who fail actually fail? The basic idea is because it's very hard from what we used to do before. We develop software differently from what we did in the past. If we take a step back and maybe zoom in on the cloud, in the cloud, we define infrastructure as anything that can be changed or provisioned or controlled through a cloud provider API. And when we think about it, it's crazy. Think even on the concept or notion of firewall, which is like a classic pillar of infrastructure. And it has been like that for the past 25 years. People have been using boxes of firewalls. You get a box, you put it in a data center, you usually wire it, and the person who knows firewall the best is the guy that dragged that piece into the data center. After a few years, with the changes of having a virtual appliance, we could have created a virtual console to change the configuration of a firewall. And today, with the cloud providers, we can provision automatically firewalls or networking configurations using API or infrastructure as code. And it has completely changed the way that we work with software. For example, dev teams in the past used to write code and toss it over the wall to the other side of the office space and ask the release engineer to deploy it into these physical servers. The operation teams used rack servers and only deployed code manually. Today, the operation teams write code and deploy the code. Servers were physical, and today they are virtual and have elastic IPs, and the connectivity as a result is very dynamic. Security became very virtual and not a physical parameter of network. And the perimeter itself is very vague. Some of it is controlled by IAM, some by networking. Usually you'll have the mix of both, and there is also the notion of data security, threat analysis, and more. Infrastructure provisioning went from manual to infrastructure as code. Server configuration went from manual to config management. Testing became automated, and the deployment cadence have changed from once in a few months to multiple times per day. And the entire change process of software applying code to production changed from ticketing to a self-serving service motion. And all of those changes both present an opportunity to apply software faster and increase our velocity as engineering teams, but it can also lead to different problems. Before diving into some of those problems, let's talk what we're going to talk about today. We'll talk about what is exactly GitOps and why it is required, what is a DAG, a directed acyclic graph, and how can we use graphs to secure our cloud deployments. Let's start with defining what is ClickOps before GitOps. So ClickOps is the action that operation teams or release engineering teams have done before we had infrastructure as code. Some of you probably have remembered that, and every time you try to use ClickOps, you usually regret it. It is the slow operation of clicking through the cloud provider console, through the AWS console, for example, in order to apply a 3-tier web application. It's slow. It takes hours to click and define a VPC, a security group, an EC2 instance, a CloudFront, an S3 bucket, and all of the different configuration to tie all of those together. There is really no reuse. Every deployment has to be done from scratch. So if I want to expand from one EC2 to multiple ones, I have to redo a lot of that work. There is no real audit trail outside of the logs of who did that action if I use the service account. And there is really a lot of tribal knowledge in those actions. And only I or the other engineer who have done this change will know how to do those steps or roll them back, assuming that the engineer that had done this change really remembers all of those steps to produce a new web application. It is very error prone and a manual task, and for that is exposed to human errors. Let's say that I clicked the wrong configuration and turned the bucket public by mistake. That's bad. And really, it's boring to do the same thing over and over again. Here comes GitOps. So GitOps is not a single product or plugin or platform. GitOps is a workflow to help manage IT infrastructure through the processes they already use in application development. GitOps requires 3 core components. You need a Git repository, which is the single source of truth for infrastructure definition. Infrastructure definition would be your infrastructure as code, your Terraform code, your Azure ARM templates, your CloudFormation, etc. This Git repository need to have the IAC within it. Git will be the version control system that tracks the code and management changes. And with that, it will track each and every change and will produce a version controlled infrastructure that has an audit trail in Git commit history. Infrastructure as code will mean that I have a set of configuration files and functions that are stored within that Git repository and actually represent the desired state that will be applied declaratively into a running AWS account. The second component is pull requests. GitOps uses pull requests or PRs as the change management mechanism for all infrastructure updates. The pull request is where teams can collaborate via reviews, comments, and where formal approval takes place. A merge commit to your main branch serves as the audit log for applying to the production environment. And the last piece is the CI/CD. GitOps automates infrastructure updates through Git workflows with continuous integration and continuous delivery. When new code is merged, the CI/CD pipeline enacts the change into the cloud environment. Any configuration drift as manual changes or errors is overridden by the GitOps automation. So the environment converges into the desired state that is defined in Git. In GitLab, it will be called CI/CD pipelines. In GitHub, it will be GitHub Actions, or you can use Jenkins or other systems, but the idea is the same. It is a workflow of applying the blueprint, the manifest that is defined in IAC and is agreed on in pull request into the production environment using the continuous delivery system. What are the problems that we've solved with GitOps by using GitOps in ClickOps? GitOps is much faster. So computers are faster than human, and it's not a slow operation anymore. We have persisted all of our changes in code, so it's reusable. And we can utilize some of our previous work when we were trying to apply a new three-tier web application. It's logged and versioned in the Git history. It's reproducible and reliable, and we can actually run tests upon our deployment. And it is not as stressful, boring, or tedious since we do it only once, and we don't need to memorize or to have a lot of fear of blackouts. So within that GitOps equation, we have the IAC. Let's drill down into the IAC piece and wonder on what is it built from. So infrastructure as code is built from a dependency graph. The concept is the same in Terraform and in CloudFormation and in serverless framework and also in other infrastructure as code frameworks. Terraform specifically is one of the most popular infrastructure as code frameworks, so we'll stick to that as the main example. Terraform builds a dependency graph from the Terraform configuration and walks through those different resources defined in the graph to plan what changes will be applied upon deployment, either deletion of an object or applying a new object or updating an existing one, and to refresh its state. The Terraform dependency graph is built from nodes, edges, and an operation called walk. Nodes would be resources, variables, or providers. Edges will be the dependencies between them. And walks would be traversing through the graph, through the different nodes on top of those edges. Let's start with an example. In this piece of code, I have an EMR. The EMR cluster is using a security group called dev. The dev security group, even though it's connected to the production data engineering EMR cluster, is using a widely open security group that has the CIDR blocks defined as the entire internet as 000 in a variable called dev CIDR block. Now, production data engineering EMR cluster should not use a publicly open security group. How does the Terraform graph looks like for this kind of infrastructure as code? We'll ignore the count boundary and the provider for a sec. And we'll see that there is actually a connection, an edge between the node of the EMR cluster, the security group of the dev environment, and the variable of CIDR block of the dev environment. So that's how the Terraform graph looks like, how the representation of code is a directed acyclic graph of resources such as EMR clusters and security groups and variables such as the CIDR block looks like. Now, the question that we want to ask ourselves if we're a security practitioner is, is one of my EMR cluster open to the world, or is using a security group that is open to the world? And to answer that question, we'll use an open source tool named ClickOps. It's under Apache 2 license. It's free to use. You can start using it by typing in pip install ClickOps, or use the Docker container, the GitHub action, the Jenkins workflow, etc. And you're more than welcome to contribute. There is more than 200 contributors helping us to maintain this piece of code. And what ClickOps does is actually inspecting our infrastructure as code and looking for misconfigurations, for example, a public security groups, but also others, like do I have all of the right settings in my version control systems like SSO or MFA and signed commits, and also other best practices in each of the infrastructure as code frameworks you can think of: Terraform, CloudFormation, Kubernetes, Helm charts, Customize, ARM templates, Bicep, and the list goes on. So let's go back to our graph and see how we can ask the question of, is our EMR security group connected, open to the entire internet? We'll start by traversing from the root to the provider that we've defined in infrastructure. So now I haven't shown you the code of the provider, but it is defined in a different file. From the root, we'll traverse into the provider looking for the EMR cluster. Good, we found one. We'll search if we are seeing any security groups connected to it. There is an edge between the security group and the data engineering EMR. Now, the security group have predefined variable called the dev CIDR block that is actually opening us to the entire internet. So Chekhov is actually building the graph and traversing it, looking for where a specific variable, like this one that is connected over here on the ingress and egress, that is connected over here in the security group reference, exposing our EMR cluster. I have a main TF file with my EMR code defined. And I have the CIDR block and some other CIDR groups. Some of them are good and some of them are bad. I've already pip installed Chekhov on my local machine. So I'm going to scan the local directory and choose a specific check called AWS_7. And the thing that I'm going to get is that I have one good EMR cluster in my code and one bad EMR cluster that is exposed to the internet. Now, Chekhov have helped me identify if my infrastructure as code is secure. But what about other services that I'm using? Infrastructure as code is covering my cloud managed services that are defined in Terraform code, but I'm also using open source packages, and they are also applied on every upgrade. And Docker images are also getting pulled before provisioning them into the production environment. And I have obviously proprietary code that I've copy paste from Stack Overflow. And I also need to inspect the CI system itself. For example, if I'm doing a change into the code, how do I know the change have come from a reliable source? Do I have SSO configured on my version control system? Is my GitHub Action workflow only accepting changes to the main branch from authorized maintainers? And what about the runtime context? For example, is this change applied to a dev environment where I'm willing to take more risks for exploration, or to the production environment where I'm not as liberate with the risks I'm willing to take? Securing cloud native application code is more complex than just securing the infrastructure as code. We have different layers. We have the cloud infrastructure that is responsible generally on compute, storage, networking. We have the container orchestration framework, whether it is Kubernetes, ECS Fargate, serverless, or a different flavor of compute, or even VMs like EC2s. And we have within the containers or the different orchestration system, we have the build templates, we have dependencies, open source packages, and custom code. And each one of those layers can actually have an issue. For example, a specific organization, for example, the bridge organization, have two repositories. It might have Go dependency package manager that is unpacking a specific Go package that is dependent on another Go package and has a full dependency tree of open source packages. Each one of them can be vulnerable or have an announced CVE. The Docker file can that wraps that specific package can utilize an old version of an operating system, an old version of Alpine, CentOS, or a different one. And my Terraform code can actually provision a publicly accessible bucket to a production errand. So there is also connection between code, the build time, and the runtime. And I can also provision plain text secrets by mistake to that public resource. Another thing that can be vulnerable in my entire software bill of material, containing both infrastructure, managed services, open source packages, containers, secrets, etc., is that actually my CI/CD system, for example, Circle CI or GitHub Action, can also be misconfigured. Can have plain text secret within it, can be exposed to shell injection attacks. And I need to make sure that even my code that is written within the workflow file is using reliable containers, and the code that I'm writing is not having any vulnerabilities or misconfigurations. So to have a full picture of our application, our graph is actually built from layers that are in the code itself, the vulnerable packages, the proprietary code. Some of them are in the images, like malicious images, or am I injecting plain text secrets? Am I vulnerable to insecure CI/CD pipeline configuration, or did I forget to enable MFA and make sure that each and every committer in my organization is from a trusted source? And obviously, the runtime aspect of it, is my code deployed to a runtime environment that has different context than my code? And all of those different issues is producing a lot of headache and tickets and a lot of graph analysis that I need to do to traverse the different connections and impact that each connection or variable or dependency might have from my code on the cloud environment. Now, to prevent those ticket scenario, I can apply the same interactions that I had in checkout on my CI/CD pipeline. I can actually install checkout on my CI pipeline and let it inspect my code and suggest common fixes for those code changes. For example, produce an automated comment suggesting me to add encryption to an S3 bucket. And I can also use the checkout VS Code extension, and using an API token from the Bridge Group platform to scan the code on the fly while I'm writing it and apply a quick fix within my IDE to add encryption and different and prevent different misconfigurations. Where if I'm applying code fixes and identifying issues very early on the IDE or the pre-commit hook, I'm having less context to what impact it might have, but I'm more productive because as an individual, as a code contributor, I have actually someone, a plugin, an open source plugin looking over my shoulder, telling me what should I change before creating noise in a pull request process or before trying to apply it to production. And I can also have it as part of my continuous deployment. I can have my admission controller, for example, if you're using Kubernetes, preventing me from applying specific misconfiguration. Or have the same process of inspecting the runtime where I have the most context on the impact that a cloud misconfiguration might have. But it's less productive because it's already on runtime, already creating noise to different operation teams, which have less control over the code. So if I do code changes that will fix and minimize the risk very early on, I will have less context on the impact, but I will be more productive. And we reduce the complexity. And on runtime, I'll have most of the context, but it will be much more complicated to apply a fix. So what are the key takeaways from today? One, we need to create a predictable deployment using GitOps. Two, we want to have a secure coding mechanism, and that will attach our context from code to the cloud runtime, going through secrets, misconfigs, CVs, image vulnerabilities, and the supply chain itself, the version control system configuration and the CI system configuration. And the most important key takeaway is that you can join the open source community of Checkout and join and contribute or open an issue or join the Slack channel of slack.bridgegroup.io and help us secure the cloud environment very early on your infrastructure as code. So thank you, everyone. I was Barak Schoster. I love the snow, the sun, and secure open source projects. And I love contributing to open source projects like Chekhov, Your, TerraGo, There I Am. And if you'd like to participate in one of them, feel free to reach out to me at Twitter, LinkedIn, follow our blog, Twitch, and I'm looking forward to see you there.